Hello, and welcome to today's webinar. My name is Adam Golov, Marketing and Communications Manager at Data Conversion Laboratory, and I'll be your moderator today. Before we get started, I wanted to let you know we will allow time at the end of the webinar for questions and answers. So please write your questions in the chat area as they come to mind. If we don't have time to answer them all, we will make them available on our website. For those of you who are not familiar with DCL, we convert and organize content to create electronic documents, populate databases, publish on the web, and basically get it ready for tomorrow's technology. Next slide, please. DCL services help you refine your document conversion strategy, identify document redundancy, extract metadata, and transform legacy and future documents for real needs, today and in the future. Next slide, please. We serve a very broad client base. Next slide, please. Spanning all industries. Today we are thrilled to introduce Don Larson, founder of Larson Software Technology, and David Manick, president of VisualSight. Don is founder of Larson Software Technology, which develops and markets graphic software tools. Over the last 10 years, Don has been active with CGM standards committees for both the petroleum, aerospace, and defense industries. Don played a role in the development of the web CGM profile, and his company was a founding member of CGM Open, an organization dedicated to open and interoperable standards for the exchange of graphical information. Currently, Don is chairman of CGM Open, working to advance the web CGM standard. Don has over 25 years in graphic software design, development, and technical management. David founded VisualSight in 2014 after leaving BAE Systems, the global defense contractor. David has worked in the technical publications industry for over 25 years. VisualSight focuses on the technical publications market, providing off-the-shelf software and services. David started his career at Lantec, Manchester, UK as a graduate entrant, where he spent 8 years in the company's technical communications department. In the early 1990s, David became the software business manager at Graphems, where he introduced a new software product exclusively to the UK market. IsoDraw, the technical illustration software, was developed by Germany-based Auto-trace-Raster Software GmbH. IsoDraw, now known as Arbortext IsoDraw, was adopted by the major defense and commercial industries, including BAE Systems, Boeing, Thales, Jaguar, and Rolls-Royce Motor Cars. In 2013, David joined the Piper Group, a wholly owned subsidiary of BAE Systems. He was appointed business manager for the company's software portfolio. His products included Trilogy, the interactive technical manual suite, now being used globally in the defense market. David was appointed to the post of product marketing manager for IT software in Cologne, Germany in 2005 before joining BAE Systems. He was appointed as the Trilogy business manager in 2009, with the role bringing him to the United States. David was appointed head of business development at BAE Systems in Orlando. The objective established Trilogy as a viable commercial product in the U.S. market. The signing of a Trilogy enterprise agreement for the F-35 Joint Strike Fighter program provided a firm market foothold. Originally from the UK, David is now based in Orlando. David is married, 1 daughter and 1 son. He lives in Winter Garden, Florida. Without further ado, welcome Don and David.
Thank you. Thank you, Adam.
Okay. Yeah, thank you, Adam, and thank you to DCL Data Conversion Labs for hosting this event and giving us an opportunity to talk about graphics. A little background on Larson Software Technology. We're based in Houston, Texas. We're a software company that develops and markets graphic software tools based on open standards. We promote the usage of CGM by providing a free CGM viewer called BizX Reader, which is downloadable from our website. Larson Software is a founding member of CGM Open, which Adam mentioned in my bio, is dedicated to developing and advancing 2D graphics, exchange of 2D graphics information, and primarily the CGM standard. Larson's products are used in technical publishing, aerospace, defense, and heavy manufacturing, and also some in the petroleum industry for exchanging graphical information. Our products are used primarily to create, maintain, and deploy technical graphics. And if you would like to learn more information about the Larson Software Technology, I've got our website up there. So now I'm going to turn it over to Dave. You've got the background, so Dave, it's all yours.
Thank you, Don. I think Don's just going to go to mute, and then he might join us at the end for some questions and answers. So thank you to Adam as well and DCL for hosting us today. So my background is technical graphics. You probably got that from my biography. So, and this is all about technical graphics, this particular webinar. So here's some of the objectives we're going to look at today. Hopefully give you some good information. So we're going to provide some lessons learned about transforming technical graphics. We want to focus on the primary source formats, which I would think you would agree are raster and vector data. We're going to describe some preparation techniques and considerations that you might need to take into account to get the best results. Highlight some of the pitfalls you might come across or already come across. Provide some tips, benefits, advice, and knowledge. So you'll see some various information that I won't go through during the slides, but hopefully if you download them later, you'll be able to get the benefit of that. And at the end, we'll just summarize the webinar, and what we've talked about is obviously graphic conversion and the transformation process. So, way of introduction. The use of technical graphics is produced in various formats, and it can be a significant challenge as part of a publications process. So, and different file formats that you might come across originating in different systems can cause you different issues and will require different resolutions to solve them. Obviously, quality is a major consideration. So you need to get good quality out of your data to get a good output or good published data. So quality is always a major consideration. And best practice will hopefully reduce the production time. So if you can refine and optimize the process, you're going to reduce your production time and obviously costs. So let's look at today's graphics process. I would say predominantly today's graphics are produced and generated in an electronic format. But they could have also come from original hard copy illustrations that have been scanned. But we're still talking about an electronic data. The most likely starting point today, you might disagree with this, but I think is probably from a CAD system. And this could be either 2D or 3D source data. And these could be used for spare parts type illustrations, schematics, and wiring diagrams. So probably the only thing that doesn't fit into this is type of maintenance type illustrations. And we'll talk about those later. So I think what you need to think about at this point is, although you've got source data that could be in 2D or 3D CAD, it could be still sometimes good to actually draw from scratch. It could be quicker, depending on what you're actually bringing in, and also the availability of the data from the CAD department. And sometimes you could create an illustration from a photograph as a template, perhaps. So this is where we're saying perhaps not everything originates from electronic kind of vector information or raster information. So what are the possible data sources? Well, I think the two primary ones I said at the beginning were raster and vector. So raster, they could be scanned line art illustrations that were done in the past, or they could be, raster files could be an intermediate format, so it could be exported from another system, another third-party piece of software, such as a CAD system. And also photographs could be used as an intermediate format. In other words, as I just said a minute ago, is actually tracing over a photograph for a maintenance type illustration. And then vector is probably more predominant now, where you would have data from a 2D or 3D CAD system. And there are many formats possible that you could get out of that system and use. Also, vector data can originate in general graphics software such as Adobe Illustrator and CorelDRAW, or be in an actual format such as PDF, where you could have embedded vector and raster data. So a lot of sources of data to create your technical graphics from. So at this point we're going to run our first poll. I think we've only got 3 polls, so we just want to try and get some information from you about your processes. So we have some questions here. And I think Adam's going to kindly open the poll for me. So unfortunately, I don't see the poll. So Adam's going to give me some feedback.
Sure, David. So right now, with about 40% of the attendees voting, so that 80% responded vector with Adobe Illustrator, PDF, or other. Numbers are changing quickly, so right now it's 65% vector, Adobe Illustrator, 13% raster intermediate format, 8% each of raster scans of original illustrations, and 8% vector CAD 2D.
Okay.
15% has said vector CAD 3D, with 80% of the attendees responding.
Okay. That's interesting. I would actually thought it might have been more geared towards the CAD side for the vector data, but obviously we've got a lot of Adobe Illustrator users out there, general graphics software.
So let me close the poll right now, and I'll read the final results for you. Okay. And they are, the final results was 59% indicated vector Adobe Illustrator, PDF, or other, 15% vector CAD 3D, 11% raster intermediate format, raster from CAD and photographic, and then 7% each raster scans of original illustrations, and 7% vector of CAD 2D.
Okay, so kind of not that much 2D CAD being used, but interesting that we've got a lot of general graphics, but we've also included PDF in that, so that's interesting as well. But hopefully as we go along, so we'll see that how this becomes appropriate to, it could be that you might have a better way of actually sourcing your graphics through CAD, through a CAD system if you have access to it. But first we're going to talk about raster data. So, and raster data I still think it plays a significant role in the origination of technical graphics, but probably only in certain industries. So it depends. If you're in, say, for instance, aerospace, then you might have a lot of scan line art of previous illustrations that have been done in the past. But it's also possible that they've then been traced over and created vectors from them. So there is various ways that illustrations are being used today and have changed in their kind of format over the years. But possibly they will, at some point, some of them have been scan line art. So we have that. The source could be photographs, scan line art, or TIFF files for delivery, perhaps. So there's various ways of delivering the files as well. So it's always a good idea, I think, if you have raster data, is to do an analysis of it. It could be beneficial in respect of optimization of the process itself, the production process. And also, raster data may require some enhancements to it. So if you're delivering, for instance, an interactive electronic technical manual, then you might need to add or enhance that in some way by adding our hotspot information. And we also have raster data as an intermediate format, which was in the poll. So it could have been that you were using that in the past and it was the right decision at the time, but now alternatives could exist. So it's probably good to analyze if you have another format that you could now export out of that system from. And photographic files as an intermediate raster file, so you could trace over the photograph if it's a maintenance type illustration, or you could just deliver the photograph and add appropriate annotations and so forth. So a hard copy scan, for instance, it's probable that the original no longer exists, so you're pretty much stuck with what you've got, and the quality and it's obviously dependent on the resolution, and that will depend on what the scan was originally. The other thing to take into account here is what generation it is. So when you start opening scans and scaling them and remapping them, then you could have issues. So one little tip here is if you do have scans, is if you want to try and clean them up, you can't really improve them from a resolution perspective, but you might be able to clean them up in some way. So you've got Adobe Photoshop and the Corel Photo Paint. Both have some good automated tools to actually clean up what we would call noise or sporadic pixels that you might find on the image. So in Corel Photopaint it's called remove noise, and in Adobe Photoshop is despeckle, and also dust and scratches. So it will remove this kind of noise data that can obviously degrade the scan. So what are the file formats for raster data? I think in my opinion, in the technical graphics arena, it's usually TIFF, because that's really the best format for line art if you've got a 2D technical type illustration. And that's sometimes got a compression associated with it to actually reduce the file size. But the other probably primary raster file is JPEG, which you've probably all come across because of photographic information. So those would be the two main ones, and then we've got others below that which are more probably suited to the web, such as GIF and PNG. But I was saying the technical publications arena, it's mainly JPEG and TIFF that we're going to be using. If you have to comply to a specification such as S1000D, which is used in military arenas, then you can put the TIFF as part of a CGM file, which we mentioned CGM Open earlier on, which will retain its quality and properties and also be combined with vector data. So you could have actually a hybrid file. So CGM would allow you to do that. So if you want to get rid of the TIFF, then you could put it as part of a CGM file. So the primary thing for raster is obviously the dots per inch. That's going to give us the resolution and the quality that we're going to get out of the file. So a good tip here is just, if you're not sure about it, just right-click on the file on your Windows Explorer or on your Macintosh. Obviously, it's going to be a different window for Macs, but you're going to see the resolution, some of the compression of the file. So it just gives you an idea of what you're dealing with. Obviously, the higher the resolution, hopefully the better quality you're going to get. Only if you go into publish to print, then you can't really do much about that resolution. It is what you're going to get. And in the electronic world, if you zoom in, then you might lose, obviously, quality as well when you're zooming in on a raster file. So from time to time, we do quick demos as well. So I'm just going to go to a viewer here. So this is a TIFF file. So just to show you the differences, if you were aware of them already, I'm just going to zoom in into this particular file. So here we've got a raster, and here we can see we get down to pixel level. This is about 200 dpi. We can see the individual pixels here on this image. So, and that's really, we can't really do much about that. When we zoom in, this is what we're going to see. If I open a vector file, the image, we're obviously zoomed out here, and we're in the webinar, so it might not be too apparent. But if I zoom in here into this area, then you'll see that as I get in, we're not really degrading the image. We're not seeing the pixels. So this is a vector file, so an electronic or mathematical way of describing this curve. So we're getting a much better quality when we zoom in this particular, in the viewer we've got here. So let's go back to the slides. Okay, so I think it's always a good idea to analyze your raster data if you still have it. It could be that you might want to manually redraw it, but this assessment would be based on longevity of the graphic and its future use. So it's kind of cost versus use. And does the legacy data now exist in CAD? It could have been actually modeled or created in CAD since it was actually originally drawn. It is possible. So you could repurpose it from the CAD data if you have the right software and tools. The other possibility you have, again using Corel Draw or Adobe Illustrator, is to auto-trace the legacy or the raster data. But my tip on this is that you perform some tests on typical files before to committing to this kind of strategy. So it could be quicker in the end to trace over and redraw it rather than auto-trace it. And the other consideration here is how many more revisions is this file going to have? Because typically if you auto-trace it, the quality of the vector image is going to be it's going to be fairly low. So actually making edits to it can be quite difficult. Whereas if you redraw it from scratch, you can draw it to a better quality. So advice there, think about the longevity of the file, but how many revisions as well you're going to have to it. So the main thing you need to think about with raster data is when you're transforming it or resizing, rotating, each of these things will degrade the data. So the technical term is called interpolation, but in basic terms it means that the pixels are being remapped. So you have to consider that when you're actually changing the image or the raster image in some way. Some of the artifacts of the interpolation process, though, can also be used to improve the appearance, although it is a bit of a cheat. So if you've heard of anti-aliasing, that is an artifact of interpolation. And also blurring and the halo as well can improve the image on the screen. And then we talked about intermediate raster data. So this there's instances where the CAD system perhaps or the graphics system didn't produce the right format for the publishing system, so they had to come out in a raster format. So the possible reasons for that is the limitations of the export options from the system, but also the limitations of the import options into the publishing software. So just if historically, if you've always done it that way, perhaps you just need to take a look back at what you're doing and see if there's an alternative. So in other words, validate your export settings being used, and also see if you can increase the DPI if you're going to stick with the raster, or go to a vector option, which will give you better quality. And I spoke about photographic data earlier on being used in the technical publications process or technical graphics. So usually, typically you would see a maintenance type illustration or photograph in this instance. So you could add value to this by annotations and highlighting certain areas or text. But also, alternatively, you could use a photograph as a template. And this happened a hell of a lot in the automotive industry, where they created a lot of illustrations by tracing over photographs. And the reason they did this was to only highlight the relevant information. So they could easily pick out areas of the photograph by just tracing over those as a line art illustration. And plus they got a smaller file size at the end, which was good when they came to publish this information as well. So we're now on our second poll. It's a pretty straightforward one, and it might seem a bit out of the course of the webinar, but it's what we're going to move on to. So when I talk about hotspots, I'm talking about hotspots that you might use in an interactive publication.
So David, with just over half of the attendees responding, we have 42% indicating in the future, 29% indicating yes, 29%, 30% indicating no, with 70% of the attendees responding. So we'll just give it a couple more moments, and I'll close the poll and read the results.
Okay, sounds like a pretty even split. It's probably what I would expect it to be fairly even, I think.
Well, I'm going to close the poll now, and the results are 40% indicated in the future, 28% indicated no, and 24% indicated yes.
Okay, so it's fairly even, although a lot more people looking in the future, which is interesting. And I think that might be the drive towards an electronic delivery of publications in the future. So obviously still a lot of print, a lot of books out there, and you know the generation that is out there as well still expects some printed matter, but perhaps that's changing, and I think we're moving into a world where electronic delivery, certainly PDF has proved that could be the way forward, or the way it will be in the future. So thanks, Adam. So the reason I mentioned hotspots was If you want to hotspot a raster illustration, then that can be a bit problematic because we're just dealing with pixels. So, so why would you want a OCR, optical character recognition, a raster illustration? And the primary reason would be to create hotspot regions, so regions that are interactive for the illustration. So you've probably all heard of OCR in the text world for bringing whole documents through and making electronic versions of. So, but we can still use the same technology in the graphics world as well. So primarily you'll see a hotspot on a spare parts type illustration, and that's what we'll look at in a second. So the advice would be here is to assess the suitability for OCR, and this would be the same if you had a document that you wanted to OCR as well. So you want to analyze really if the characters are sufficiently formed to make the OCR viable. So the best thing to do is take a subset of the data or illustration to determine that viability, and then use those test results. So if they pass, then you could probably go through and OCR all the files or all the graphics. If not, then there are probably two options you have, is to regenerate the required text and add a hotspot to it, or manually hotspot the raster data, so put an overlay over it, which is quite common. So we now got another short demo. We'll look at automated hotspotting, and we're looking at raster data. So I'm just going to open a TIFF file, and let's just open that up. It's actually the one I opened earlier. You can see the section marks that I zoomed in on. So all the numbers on this are not text, they're just scans, they're just pixels. So if I wanted to hotspot this, then I've got two choices. I can try and automate it by doing the OCR, or I can manually go over this. So you can see manually is going to take me a while. There's quite a few hotspots on here. So this particular tool enables me to set some parameters for the OCR, so I can set the number of characters I want to actually be recognized, and also in the OCR bit here, what's my confidence factor on this scan? You know, what's the quality of it? So I've done a bit of work on this before, so I'm just going to cancel this, and I'm going to fire up the auto hotspotter, and it doesn't look like it's done anything at first, but you might have noticed that this tree has been populated here, and all these numbers now have been hotspotted. So that was literally seconds to do that. So that's going to save me a lot of time. If the detail up here isn't hotspotted, if that didn't come through, then I still have the option to, and this is where we're talking about layers. So I could zoom in on this particular area, and I can create a hotspot area, and I could give it a screen tip. So you could also manually or overlay a hotspot over that as well. So two real ways of doing that. So let's go back to the slides. Okay, so we're going to move on to vector data, which is probably more common nowadays, but wanted to give you that overview of raster just in case you had it. So vector data, it can also be in varied formats. In the majority of cases, I would say it's preferable to raster data. So this is what I was talking about. Look at the longevity of the file. Is there a cost saving by actually regenerating it? And obviously one of the big benefits of vector is it can be scaled, and we retain the quality, which is obviously good if we want to publish this to paper or to the screen. And also you can use like anti-aliasing, as you can with raster data, to make the quality look better on the screen as well. So the main or the most common sources of vector data, I would say, CAD systems, general graphics software, the file format PDF, and also sometimes technical writing software, which is probably rarer. So to look at CAD systems to begin with, if you have these within your company, they're all great sources of information to create your technical graphics from. So these are what I picked out as probably the biggest, but was the most common. There are a lot of others as well. It would be a long list if I put all of them up there. But you've probably heard of some of these. Obviously, AutoCAD is very common, and Creo, which is probably formerly Pro Engineer. So I think it could be our last poll. I think it is. So just to give an idea, if you do have CAD systems within your company, which ones are you using? I think Adam's going to run that for me. My guess is that the winner is going to be Autodesk, but I could be wrong. Predominantly these are 3D as well.
So right now, David, we're about 40% of the attendees voting. We have a split of 31% with Siemens NX and 31% of SolidWorks, and then another split, 15% of CATIA and PTC Creo Parametric with 8% on Autodesk.
Wow, that's surprising.
So we'll give it a couple more seconds
Yeah.
for some more people to vote.
My guess would have been Autodesk, but there you go.
And we'll close it now. And the final answers was 29% split between SolidWorks and Siemens NX, and equal split 14% between PTC Creo, CATIA, and Autodesk.
Okay. Yeah, so it probably just shows I probably could have opened that up with Autodesk and put Inventor, which is their 3D system, which probably it might have got more votes, but I think the predominance of 3D now is out there for modeling, equipment, and so forth. There is still 2D because there's still kind of wiring diagrams and schematics that have to be generated, but obviously for the parts themselves, then probably going to find 3D data. Okay, just so to look at the CAD file formats then. So there's various choices here. There's native file formats. When I say native, I mean they are used internally within the software. DWG is a native file format to AutoCAD, but it is used a lot by other software as well. But then we have other options to get hold of 3D CAD data, which are open formats, Vermal, IGES, and STEP. In my experience, IGES is usually a good choice. It's a rich format, not too big, although all 3D files tend to be big, and you'll get the really good quality if you want to. If you can't support a native file format. With 2D, then we have DXF, DWG, but you could also add to that list probably CGM and also PDF as well. And we'll discuss those formats in a bit later on. So I've got a 2D file. So this is another short demo. I'm just going to close this file down. And I'm going to open a DWG file. So this could be a schematic, or it could be a projection of possibly of an illustration. So let's just open this file up. The first thing that comes through is, and this is, again, you get this with CAD, is that not as much with 3D, but certainly 2D, you'll get layers that have been set up in the CAD system. So what I've got the option here is to eliminate certain layers. This particular CAD file has actually got foreign languages on as well. So I can take those out. If I leave them in, let's just open it up. You'll see I've got a lot of data that I don't need. I'm really only interested in the illustration, but I've got here all the legend and so forth, which is not really something I need at the moment. So if I reopen the file, then you'll see with that options window that I could actually eliminate some of those layers. I need a bit of intelligence about the file. So I've got that in this particular file. I know which layers I need, which is 0 and dtext. I can also bring this in as a monochrome because sometimes you have colors that come through in CAD files, and I probably don't want those. I might want a line art illustration, a black and white illustration. So let's just bring this in. So you can see now I've eliminated a lot of the information. I could easily get rid of this particular this legend down here. And I'm just going to zoom in on this file here and just show you some of the difficulties that you can have with CAD data is that it doesn't support sometimes Bezier curves, although there are tools that can optimize this. But this is just little straight lines, what we call polylines. So this adds to the file size, but also you can imagine trying to edit this. We're editing individual points, which is not going to be too easy. So something to bear in mind. The other thing we've got here is we have got text, so that is useful. So this should be quite straightforward to hotspot. So this is going to use an OCR because we've hotspotted this one as well. So the text is actual text, so that's useful. But we'll also talk about text in relation to CAD as well, because that can cause difficulties. So let's go back up to our slides. So what are the takeaways we've got from the CAD data? So things you need to kind of consider is if you're handling 3D data, the file sizes can be challenging, they can be big. So you want to try and optimize those as much as possible before you start using them. Polylines, we've seen that just now, that the CAD files can contain these little straight lines or polylines which increase file size but also make editing difficult. So also conversion to a 2D file format might be possible. For example, you might be able to use CGM and then use that to publish the file straight out. So it could be possible just to take out a CGM rather than go through another format. We also be nice if we could remove layers and legends and text either at source before it comes in or when we bring it in. So really you need to automate this to be cost effective. So editing, you can see the polylines are going to be difficult to edit, not like a Bezier curve that you would have in, say, Adobe Illustrator or Corel. And sometimes to bear in mind that text can also be converted to vectors, so you'd lose that property of the text. So text mapping can be an issue. And font substitution, so substituting one font in the CAD system to another when you bring it through. Another thing, a factor is character positioning as well. This is can be a factor if you've got, especially in wiring diagrams, is that if you've got text in a tight area, what you don't want is actually covering or obscuring part of the illustration or the wire itself. So always keep that in mind when you're importing CAD data. So moving on, we've obviously got quite a few general graphics softwares users out there. So the main two you're aware of probably are Adobe Illustrator and Corel. I would say those are the dominant two general graphics software packages on the market. File formats, probably the one I missed out here when I look here is EPS, but you've got Adobe Illustrator, PDF, which in some ways is actually beginning to replace EPS. And we've got DWG and SVG, which are also usually present in graphics software. If you're in a specification-driven industry, then you're going to have to look at something like CGM as your format, which gives you compliance to S1000D and commercial aerospace standards. Just a tip here that Corel Draw X7, the standard program, does support CGM, but doesn't support the profiles required for specification compliance. So just kind of bear that in mind if you have customers or you're a part of the aerospace industry or defense industry. So it's a very good choice for export formats. PDF is an open format now, so good potential to use in an archive. There's also SVG or Scalable Vector Graphic, also an open format. My advice here is I would think about not using this as an archive, mainly because of its interoperability. it can export good quality, but doesn't always bring back in what you would expect. So be careful with SVG as an archive format. Usually the file sizes are very good and usually small in the graphics world. And there's obviously good compatibility with your publishing software, be it kind of InDesign or Quark or whatever publisher software you're using. So advice here is if you're in a compliance situation, if you're in the defense industry or commercial aerospace, then CGM is going to be the format you're going to need to use. So, and not all these graphics software, in fact none of them actually support that particular or the profile of CGM that you're going to need. The other thing you need to take into account is hotspotting. So if you're in an interactive electronic technical manual environment, then you're also probably going to need to use CGM as your format. And finally, if you're again you need compliance, you could use TIFF, the raster format, but that's probably not ideal. We also have specialist illustration software. So you have your general graphics, but we also have a specialist area for creating technical graphics. So one mentioned earlier that I was a part of it was IsoDraw, which is still around today from PTC. Then you have Corel Design X7, so it's actually Corel, but it's the designer which is actually specifically aimed at the technical illustration market. And both those have 3D import capabilities. We have Larson's Vizex Edit, which I've been using for the little demos today, which is a native CGM editor. We have an Auto-Trace Tech Illustrator, which is probably not as widely used as some of the others we've been speaking about, and some others. But Cortona have a product for technical illustration, and then Antea have a very specialist application that works with IsoDraw and Corel, which gives you some nice tools for working to the specifications again, create symbols and annotations to the spec of S1000D and ATA. And then we have more specifically 3D illustration software. So PTC have a product called Creo Illustrate, then there's a 3D Via Composer, and Cortona's Rapid Manual. So you can research all these pieces of software. So we've got a definite split here now in the 2D and the 3D world in the illustration software business. So what are the takeaways? I would say that these specialist software, they're used in all areas of industry. So not just aerospace and defense, they're used in commercial areas as well to speed up the graphics process. The cost is generally higher, but you make up for that in specific functionality and get your return. Very good choice for import and export formats, very good handling of both 2D and 3D files, and good compatibility with publishing software, especially if you're going to an electronic manual. So the next topic is PDF. I don't know if the attendees know, but in 2008 that PDF became an ISO standard, which means it opened it up. Although it's Adobe invented it or developed it, it is now an ISO standard. So the releases are governed by ISO. And I think the mission of PDF was always to be interoperable, you know, move it around easily between different software. But I think now the organization of ISO behind it even strengthens that even further. So PDF was based on PostScript from Adobe, and it does support graphic primitives, so which is interesting for us because we can actually use it as an archive. So it supports lines and Bezier curves, but it also can contain raster data as well. So the benefit is you can open the PDF in different graphics programs and edit them. But just some advice here that not all PDF files are created equal. Some of the older PDF files didn't contain that vector structure, so you might not be able to edit the graphic that was embedded in them. But you could also use PDF from an export from a CAD system as well. So I think this is our final little demo we've got today. And I'm going to open a PDF file. Let's just choose PDF here. So this PDF, it's got text, and if I zoom in, you'll be able to see that it's vectors as well, and it's editable. So in theory, I could use that as an archive format. Just be careful. Not all software does support opening a PDF, reopening a PDF, and seeing the vectors. So just do a quick test on that. Obviously, Adobe Illustrator would and Corel, but there could be other pieces of software that don't support it. So it could be that it does have the properties, but the software is just not capable of it. So you can see this is text, and then we have the graphics here that I could change and edit and then re-export. So that was our final demo. Probably the lowest one here, or lowest common denominator, is that if you've got another source for your technical graphics, then was when it was embedded into your technical writing software. So this could also include Quark and so forth. And it could be the only copy of the illustration you've got. There is no other place that it resides anymore. It's been lost, or the customer doesn't have it. They can only give you the graphic embedded into that technical document. So, but there are ways and methods for retrieving the data, so don't give up on it. There could be a way of getting that data out, either in raster or vector form. So just to sum up, we mentioned CGM at the beginning. This is obviously a format that we've talked about during the presentation. We talked about PDF, but also consider CGM as a good format. It contains both raster and vector. It's non-proprietary, and it's governed by the CGM Open Foundation. It supports the specifications such as S1000D and ATA. It's interoperable, and it can contain metadata such as hotspots. So it's got a lot going for it, along with the other formats we spoke about today. So best thing to do, always analyze what you need for the customer, but also for the quality, and then choose the right format that you want to use as your source data. So in summary, I think there are a lot of opportunities to source information to produce technical graphics today. In the past, perhaps it was always, let's just draw it and we'll get on with it. But now you need to look at where we can originate data from. Is it in the CAD system somewhere that we can get that data, or was it an original scan that we can reuse? So the formats are diverse. As you've seen today, there's a lot of formats involved. So you build up that knowledge over the years as what's the best quality format for me, and then how we're going to publish that format out. And you don't want to have too many files for configuration control issues and revision issues. You want as fewer files as possible in the production process. But primary considerations are always quality and reuse in the publishing environment. So you need a format that's flexible. And also the software you choose as well needs to be flexible. And you might not only be one, that you might need a combination of solutions, not just one. So I hope today's webinar has been informative, and I hope you found the demonstrations, the polls, and everything else interesting and useful. And at this point, we're going to open up, I think, for some questions. So I'm going to call back in Adam at this point.
Well, thank you, Don and David, for a very informative webinar indeed. We have several questions that have been submitted. The first one being, are there any downsides to using CGM and PDF as export formats from CAD systems?
Yeah, Dave, I'll probably take that one. Okay. Well, I think the first obvious one is that of the 5 CAD systems that we took the poll on, AutoCAD and SolidWorks don't support CGM export. They only do PDF export. In general, I'd say CGM is preferred if it's available, because CGM has more intelligence and metadata in it than a PDF does. So PDF is a flatter file, whereas CGM can actually have ellipses and circles, the geometry for them. So the other obvious downsides, which we talked about, is that when you're exporting from CAD, you're going to probably get a 2D drawing that has a title block, borders, a lot of ancillary information that aren't appropriate in putting in a presentation. So you need a way to, hopefully you can either turn off the layers when you're exporting, or have software that can deal with layers, let's say. So that's probably it. I think one other thing to watch out for is some export tools, CGM exports, have options to make the text as graphic. So again, as we had talked about, you want to, if you want a hotspot, you're going to want to keep that text as text rather than the graphics, because once it turns into little vectors, you can't hotspot it, or it's much more difficult to edit and change the fonts. So I think that's probably all the things I see right off.
Excellent. Well, thank you, Don. The next question has come in is it possible to batch convert graphic files?
Yeah, I think I'll take that one, Don. Yeah, it's one thing we didn't really touch on today. We just did processing of individual files, but the answer really is yes. There's different technologies out there to do batch processing of CAD information, but also raster information, and also automate that hotspotting as well. So the answer is yes, but you obviously need the technology to do that. And also the files need to be of a good quality. You don't want to be running through files that are just giving you not very good output, which you're still going to have to do a lot of work on. So, but yes, you can do batch processes of these files.
Great, thank you, David. The next question has come in is why was CGM chosen as the graphic format for the S1000D and the ATA and the ATA specifications?
I think that one's on me as well, because I've got a long background in the specifications. Well, but predominantly when it was set out, the two organisations wanted a format that was open. They didn't want to go down a proprietary route where a particular vendor was in control of the format. And CGM kind of fitted that bill. And plus, it could actually contain both raster and vector data. So with legacy, which is there's still legacy there, so you could put the legacy in there and create along with the vector and have a hybrid file. So that was important. And then along came later on was the hotspotting and so forth. But primarily at the beginning, it was chosen because it was an open format. So that's pretty much it. It's open.
Thank you, David. The next question has come in is which graphic file formats support hotspots?
Okay, I'll take that one. Well, the two formats, well, in the context of what we've talked about today, would be, there may be others, but it would be CGM or SVG. Technically, you can do a hotspot, kind of a rectangular hotspot in PDF, but I've rarely seen it used, and it's not very well supported. So it'd be CGM and SVG. The difference there being, though, is CGM has an actual specification for defining how hotspots are done. That's part of the S1000D and Web CGM specifications, which is a W3C standard, whereas SVG has many ways to do it. I've seen many ways that hotspots could be implemented in SVG, and that was, and David touched on this a little bit, that's the main difference between CGM and SVG is there's an actual specification for hotspots and a profile as part of S1000D, whereas in SVG there's not. So those would be your two, and the differences and cautionary notes about using one or the other.
Yeah, I concur with that, Don, as well. Yeah, that's pretty much the kind of situation with the two formats.
Thank you, gentlemen. The next question is coming in is, would you be able to, can you show us how you use the hotspots?
I don't think we've got that in a part of this demo. So we'd have to be able to show you an IETM if that's what the question is. So the answer is yes, but probably not today. But we could take that offline if the particular person wants to see a demonstration of that.
Okay, thank you. The next question that has come in is, what do you mean by archive format when you say SVG might not be a good choice?
It's mainly because, and Don might want to help me out on this, but from our experience is that you can export an SVG, but when you try and bring it in, you might get a different result to when you actually exported it. And especially if you actually moving it between different pieces of software. So we call it, it's not interoperable. So you get inconsistencies when you might bring it in from one piece of software to another, or even the same piece of software. So that's what we call as an archive. So what we're trying to achieve, I suppose, is one file format that we maintain, rather than, say, two, a native format and then one we export. So that's really the caution here, is don't use it as your single format for import and export. Don, would you agree?
Well, I could just elaborate a little bit. I agree with that too. I mean, this round trip issue with SVG, you can see it in Illustrator. You can export it from Illustrator and then turn around and read it back in, and it may break up some of the paths and the subpaths and stuff like that. It's even worse if you use, like, there's an open source SVG editor, which is nice for creating them. It's called Inkscape, and it's open source, and it can create a good SVG, but you have trouble coming back, and especially if you go from Illustrator to Inkscape or something. So it just emphasizes, I want to just emphasize the interoperability issue. Now, if you put them in a browser, if you put them in Internet Explorer to view them, or Chrome, I mean, it's a nice thing. You can view it in any of the browsers. You should get the same results, or pretty close. I've seen some issues, but so it's interoperable between viewers, but not between editors.
Thank you, David and Don. The last question that's come in is there a standard export settings for CGM files?
I'm going to let you take that one.
Well, I guess it depends on the software, the CAD software. You just probably want to leave, if it has an option, for instance, text as graphics, you probably want to leave that off. You know, I'm not familiar with the exports. I know Unigraphics has a real good export, CGM export. I know a lot of you are using Unigraphics, so I could try to get you some more information on that from a Unigraphics operator. But yeah, so I just say you want to get the best, most intelligence if there's settings like that related to what it does with text and compression modes for the embedded raster data and stuff like that. You want to get the best you can get.
I suppose you could also be talking about export from the graphics, from the illustration software as well. And most of those specialist software give you the different profiles that you're going to export the CGM in. So you can export in, say, the Web CGM profile or the S1000D profile. So that would mean that you've got pretty much a compliant file. So it depends where you're exporting the CGM from. If that was a general question about CGM. So there's two ways of looking at it. If you're using it as a way of importing data, or a way of actually getting it to the target publishing system or interactive electronic technical manual.
Yeah, one point I could add to that, when we're talking about graphics export from illustration software, there's two encodings for CGM. One is text encoding, and one is binary. And most generally, the binary is the most widely supported. So that may be another consideration.
Well, thank you both, David and Don. Appreciate it. And thank you, everybody, for attending today's webinar. This will conclude today's broadcast. You'll be able to access the recorded version of today's webinar in the archive section of our website located at www.dclab.com. Our next webinar will be next Tuesday, November 17th at 1 p.m. Eastern Time, titled Preparing Your Legacy Data for Automation in S1000D, being presented by Nave Greenberg, Director of U.S. Defense Development, DCL. Thank you, everyone, for attending, and have a great day.
Thank you.